Hello and greetings, my summer AP Calculus scholars. Here we are at section 1.4, parametric equations. And I believe section 1.4 is where you're probably going to hit some stuff that you have not yet seen for the first time here in AP Calculus. So here are our learning goals for the section. We're going to graph curves with these parametric equations. And then we're going to find the parameterizations of circles, ellipses, and line segments. So let's jump in and get started. Okay, first some basic vocabulary terms for you. First of all, what are these parametric equations? Parametric equations are x is equal to f of t and y is equal to g of t across an interval of t values. And simply what that means is both x and y are functions of this third variable t. And typically what we have is y is the function of x. So we get to choose whatever we want for x, and then y will change depending upon what we choose for x. Well, in parametric equations, x and y are both functions. So when t changes, x is going to change as a function of t, and so is y. Parametric curve. The parametric curve is the set of the xy points, or the set of f of t comma g of t points. And that simply means a parametric curve is a graph of the parametric equations. The parametric interval, that's the prescribed t values for the functions. The initial point, which we're going to abbreviate the IP, if the parametric interval is from a to b inclusive, then the point f of a comma g of a is the initial point. And all that means is it's the starting point. So if we have a t interval that goes from a to b, when we put a into the f of t function for x and a into the g of t function for y, that's going to give us the coordinates of our initial point. And then similarly, our terminal point, the TP, that's the ending point or the stopping point. So the terminal point is the values of x and y, or f of b comma g of b, that we get by putting the b value or the end of our t interval into our parametric equations. Okay, now that we kind of know what they are, let's try to graph one with our fancy calculator. And the one we're going to graph is x is equal to t squared and y is equal to t squared minus 4t, and our parametric interval, or our set of t values, goes from -2 less than or equal to t less than or equal to 2. Okay, so we're going to graph this. So go ahead and grab your Inspire. If it's not handy, pause the video quickly and go grab it. But here we go, we're going to graph it. Here I am at my home screen, and I need a graph, so I'm going to select the graph, and then default is a simple function, but that's not what we're looking for, so we need to go to menu and choose our graph type and go down and select parametric, and you'll see the window will pop up with an x1 of t and a y1 of t for us to enter our functions. And let's see, our x function was t squared, so go down here to our keyboard and get t and square it, and then enter our y function, which was t squared minus 4t, so t squared minus 4t. And then we get to our parametric interval. And by default, the calculator is set at a parametric interval of 0 to 6.28, and that 6.28 is simply 2 pi in disguise. So the default interval is 0 to 2 pi. We're going to change this interval though, because our prescribed t values were -2 to +2. So we're just going to change those. And then this t-step, quite frankly, I'm not sure why they've chosen 0.13 to be the t-step. But what I do know is that that's perfectly fine for anything that we need to do, so we're just going to leave that default t-step at the 1300ths as it's set. Okay, so we have our functions in, we have our t interval, let's hit enter. And here, let me just move this function, the function rules out of your way. There you can see that's a graph of our two parametric equations. So not typical graphs that we're used to seeing. Parametric graphs can be very funky and really quite cool, depending on what your functions are for your x of t and your y of t. Okay, so that's how we graph them. So let's go back. And there you can see the screen that we entered and then a picture of what we saw. Okay, parametrizing circles. This is exploration 1 on page 31 of your textbook. If you're reading through the section, that's where you'll find this example. And exploration 1 says we're going to let x equal a times the cosine of t and y equals a times the sine of t. And in part 1, we're going to assign an a value to be 1. So that's going to change our parametric equations to simply x is equal to the cosine of t and y is equal to the sine of t because the coefficient is just 1. And our t interval is going to be from 0 to 2 pi. So again, let's grab our Inspire here and let's graph that. So I'm going to get rid of my old one. I don't need that. I'm going to get a new one up. Go to menu, get our parametrics up there. So x was the cosine of t. So to enter cosine, we're going to hit our little trig button here. And you can see all of the different trig functions. We're going to select the cosine of t. And then our y value is the sine of t. So again, we're going to hit the trig button and we're going to enter the sine and sine of t. And then I believe we were at 0 to 2 pi. Just let me double check. Yes, we were. So we can leave this 0 to 6.28, which is simply 2 pi as is, and hit enter. And look at that. X of t equals the cosine of t and y of t equals the sine of t. Looks like we have nothing more than a unit circle here, a circle of radius 1. So that's what we get when we graph x of t equals cosine of t and y of t is equal to sine of t. So let's go back. And there you go. You can see that is what, that's a picture of what we just graphed. Okay, part 2, we're going to change and we're going to let our a value be 2 this time. So let's go back to our Inspire. And let's see, I'm just going to edit the one I have. So I'm going to hit tab and then I'm going to arrow up. And that's going to bring me back to the one I initially graphed. And instead of cosine of t, in this part, we're changing the a value to be 2 cosine of t and 2 sine of t. So I'm simply going to sneak a 2 in front of my cosine and in front of my sine. And I'm going to hit enter. And what we see here is we have a circle also, but this time our radius is now 2. So we're going to go back here, and when a was 1, we got a unit circle, and when a is 2, x is 2 cosine of t and y is 2 sine of t, we got a circle of radius 2. So the next part says let a equal 3, and probably you're going to figure out and guess that what we would get would be a circle of radius 3. And that is absolutely correct. So the question is, how does changing a affect this graph? Well, a was 1, circle radius 1. A was 2, circle radius 2. A was 3, circle radius 3. So how does changing a affect the graph? A is the radius of the circle. Okay, so you might be wondering, well, geez, why does that work? Why are those two parametric equations giving us a graph of a circle? Well, let's think back to what the equation of a circle is. The equation of a circle is x squared plus y squared equals the radius squared. So if we do some substituting, x we said was the cosine of a, and y was the sine of a. So let's put those into the circle equation. So we're going to do x squared. That's going to give us a squared cosine squared plus y squared. That's going to give us a squared sine squared is equal to the radius squared. And then over on the left, let's factor out that a squared. So we get a squared times cosine squared of t plus sine squared of t is equal to the radius squared. And then cosine squared of t plus sine squared of t, that should be familiar to you. Hopefully you're remembering that that's one of our trig identities. And that trig identity is that cosine squared plus sine squared is equal to 1. So that changes to simply a squared times 1 is equal to the radius squared, which means a squared is the same as the radius squared, and therefore a is the radius of the circle. Pretty cool, huh?